Imagine walking across a desert so vast that it's roughly the size of China or the entire United States. Now imagine that same desert, but covered with millions upon millions of crescent-shaped holes, each one carefully dug by hand. Sounds impossible, right? Like someone's fever dream after too much time in the sun. But it happened. And it didn't just happen, it worked. So well, in fact, that it turned one of the most hostile landscapes on Earth into farmland. Keep watching, because this might be the most ambitious landscaping project you've never heard of. The Sahara Desert. Nearly 3.5 million square miles of sand, rock, and why would anyone live here? It's the largest hot desert on the planet, stretching across 11 countries and covering about 30% of the entire African continent. To put that in perspective, you could fit the entire lower 48 states of America inside it, and still have room left over for Portugal. For most of human history, the Sahara was exactly what you'd expect from a desert. Hostile. Dry. The kind of place where water is more valuable than gold and shade is a luxury reserved for the extremely lucky, or the extremely dead. Annual rainfall? Try less than 3 inches in most areas. Some parts go years without seeing a single drop. The temperatures regularly hit 120 degrees Fahrenheit during the day, then plummet at night. It's a place that actively tries to kill you. But here's the thing about humans. We're stubborn. Magnificently stubborn. And nowhere is that more evident than in the Sahel region. The semi-arid zone that acts as a buffer between the Sahara Desert to the north and the more fertile savannas to the south. This is where our story really begins. The Sahel stretches about 3,400 miles across Africa, from Senegal in the west to Sudan in the east. It's a transition zone, caught between the desert trying to swallow it and the grasslands trying to hold the line. And for decades, the desert was winning. Hard. Starting in the 1960s and getting really bad in the 1970s and 80s, the Sahel experienced what scientists politely call severe drought conditions. That's academic speak for people were starving, and the desert was expanding south at an alarming rate. The Sahara was creeping forward like the world's slowest but most effective invasion force, consuming about 30 miles of land per year in some areas. Trees disappeared. Grass vanished. Topsoil, that precious layer of earth that actually grows things, simply blew away in the wind. Millions of people faced famine. Livestock died. Villages emptied. It was an ecological catastrophe playing out in slow motion, and nobody seemed to have an answer. Enter a handful of farmers in Burkina Faso, who decided that maybe, just maybe, there was another way, and their solution: dig holes. Lots and lots of holes. Specifically half-moon-shaped pits called zai in the local language, or demi-lunes if you're feeling French. Either way, they're basically crescent-shaped holes in the ground, and they're about to save a continent. Let's pump the brakes. The zai technique is old. Really old. Indigenous farming communities in West Africa had been using variations of this method for centuries, possibly even longer. But here's where it gets interesting. Passed down through generations and nearly forgotten during the colonial period, suddenly became Africa's secret weapon against desertification. So what exactly is a zai pit? Picture a crescent moon. Now imagine that crescent carved into the earth. About 8 to 16 inches wide and maybe 4 to 8 inches deep. The opening of the crescent faces the prevailing wind direction, which in the Sahel typically means it's oriented to catch whatever rare rain might fall. The curved shape isn't just for aesthetics. It's functional. Brilliantly functional. When rain does fall in the Sahel, and remember, we're talking about a region that might see 8 to 20 inches per year if it's lucky. Most of it just runs off the hardened, compacted soil. The ground is so degraded that water can't penetrate. It's like trying to water a parking lot. But those little half-moon pits, they catch the water. They hold it. They give it time to actually soak into the earth instead of evaporating or running off to wherever runoff water goes to feel useful. But wait, there's more. And this is where it gets clever. Farmers don't just dig these pits and call it a day. They fill them with organic matter, manure, compost, whatever decomposing plant material they can find. In a landscape where organic matter is about as common as a Starbucks in the middle of the Sahara, this is a precious resource. Some farmers even add termite mounds, crushing them up and mixing them into the pits. Why? Because termites. As it turns out, are excellent soil engineers. Their mounds are rich in nutrients and help improve soil structure. The combination is almost magical. The pits catch water. The organic matter holds moisture, feeds the soil, and attracts termites and other decomposers. These organisms create tunnels and channels in the soil, improving aeration and water infiltration. Seeds planted in or near these pits suddenly have a fighting chance. In a desert. Let that sink in for a moment. The technique started spreading in the 1980s, largely thanks to a farmer named Yakuba Sawadogo in Burkina Faso. Yakuba wasn't a scientist. He didn't have a PhD in agricultural engineering. He was just a farmer who refused to accept that the desert had won, while others abandoned their land and migrated to cities. Yakuba stayed, and he started digging. He modified the traditional Zai technique, making the pits larger and adding more organic matter. He experimented with different tree species, planting them in his pits and protecting them as they grew. People thought he was crazy. His neighbors mocked him. Some even accused him of witchcraft, because apparently successfully farming in a desert is suspicious behavior. But here's the thing. It worked. Yakuba's land started turning green. Not overnight. This isn't a Disney movie. But gradually, season by season, his 70-acre plot transformed. Trees grew. Crops produced yields. Wildlife returned. What was once barren land became a forest. In the middle of the Sahel, in the middle of a drought. Word spread. Because let's be honest, farmers are skeptical people. They have to be. Their lives depend on what works, not on what sounds good in theory. But as Yakuba's success became impossible to ignore, others started digging their own pits. Then more farmers. Then entire communities. By the 1990s and 2000s, the technique had spread across Burkina Faso, Niger, Mali, and other Sahel countries. International organizations and NGOs took notice and started supporting the expansion. Training programs popped up. Farmer-to-farmer teaching networks formed. Here's where the numbers get absolutely bonkers. Farmers have dug Zai pits across approximately 1.2 million acres of land. That's an area roughly the size of Delaware, across the entire Sahel region. Estimates suggest that over 7.4 million acres have been rehabilitated using Zai pits and related techniques. Some sources put the number of individual pits at well over 100 million. Others suggest it could be several hundred million. Think about that for a second. Each pit is dug by hand, with a hoe or a simple digging tool, in soil that's often so hard it might as well be concrete, possibly hundreds of millions. It's one of the largest coordinated manual land restoration efforts in human history, and most people have never heard of it. The impact is staggering. In areas where Zai pits have been implemented, crop yields have increased by 50% to 200% compared to traditional methods. That's not a typo. In some cases, farmers are getting double or even triple the harvest. Sorghum and millet, staple crops in the region, are thriving in conditions where they previously failed. But the benefits go far beyond just growing more grain. The pits have helped regenerate entire ecosystems. They provide organic matter that feeds the soil. Trees planted in the pits mature and spread their roots, stabilizing the ground and preventing erosion. Their leaves drop and decompose, adding more nutrients. They provide shade, which reduces evaporation and creates microclimates where other plants can establish. The water table in some areas has actually risen. That's right, in one of the driest regions on Earth. The water table is going up because millions of tiny pits are giving rainfall time to percolate into the ground instead of evaporating or running off. Wells that had run dry are producing water again. Springs are reappearing. Wildlife is returning. Birds, insects, small mammals, all coming back to areas that had been ecological dead zones. The biodiversity increase isn't just nice for nature documentaries. It's functionally important. More species means more resilient ecosystems. Predators return, which controls pests. It's ecology 101. Except it's happening in reverse. In a desert. Because people dug some holes. Each tree that grows in a Zai pit pulls CO2 from the atmosphere and locks it away in wood and soil. Millions of trees mean millions of tons of carbon captured. The Great Green Wall Initiative, which aims to create a barrier of vegetation across the Sahel, incorporates Zai pits and similar techniques as core strategies. The goal is to restore 247 million acres by 2030. It's possibly the most ambitious environmental restoration project on the planet, and it's built on the foundation of half-moon holes in the ground. Now let's talk about the human impact, because this isn't just an environmental success story, it's an economic one. Families that were facing starvation now have food security. Farmers who were considering abandoning their land are staying put. Some are even turning profits, selling surplus crops at markets. Women, who do much of the agricultural labor in the Sahel, have particularly benefited. Better crop yields mean more food for their families and more income. Some communities have used the increased productivity to invest in schools, health clinics, and infrastructure. Kids who might have grown up malnourished are getting proper nutrition. It's a ripple effect that touches every aspect of community life. And here's something that doesn't get enough attention. The Zai technique is low-tech, low-cost, and doesn't require external inputs. You don't need tractors. You don't need irrigation systems. You don't need expensive fertilizers or genetically modified seeds. You need a hoe, some organic matter, and a lot of hard work. That means even the poorest farmers can implement it. There's no dependency on foreign aid or corporate supply chains. It's resilient. It's sustainable. It's scalable. That said, let's not pretend it's easy. Digging Zai pits is backbreaking labor. In hard, degraded soil during the dry season, which is when the digging typically happens, before the rains come, it can take an hour or more to dig a square meter filled with pits. A single hectare, about 2.5 acres, might require 12,000 to 25,000 individual pits. That's weeks of exhausting work. Some farmers have found ways to make it less brutal. Farmer associations organize communal work parties where communities dig together, rotating between farms. It's faster, it's social, and it distributes the burden. Others have experimented with animal traction or modified tools to speed up the process. But fundamentally, it's still manual labor on a massive scale. Climate change is adding new complications too. Rainfall patterns are becoming more unpredictable. Some years see floods instead of droughts, which can wash out pits. Other years, the rains fail entirely. Farmers are having to adapt, adjusting pit sizes and locations based on changing conditions. It's an ongoing challenge. There's also the question of maintenance. Zai pits don't last forever. They need to be redug every few years as they fill with sediment and organic matter. That's actually a good thing in terms of soil building, but it means the work never really ends. And if a farmer gets sick, or has to leave for economic reasons, or dies, those pits can quickly degrade. Land tenure is another issue. In many parts of the Sahel, land ownership is unclear or contested. Farmers might be hesitant to invest tremendous labor in digging thousands of pits if they're not sure they'll own the land in a few years. Some communities have worked out traditional agreements, but it remains a barrier to expansion in some areas. Despite these challenges, the technique keeps spreading, and it's not just Zai pits. Farmers are combining them with other traditional and modern techniques. Farmer-managed natural regeneration, where farmers protect and manage trees that naturally sprout on their land, is being used alongside Zai pits. Stone lines, which slow water runoff and catch sediment, are often constructed in combination with the pits. Rainwater harvesting structures complement the system. It's becoming clear that Zai pits aren't a silver bullet. They're one tool in a toolkit, but they're a damn effective tool. And they're being wielded by millions of farmers who are fundamentally reshaping one of the most challenging landscapes on Earth. The scientific community has taken notice too. Research papers are being published documenting the effectiveness. Universities are studying the techniques. Yakuba Sawadogo, the farmer who popularized the modern Zai technique, has received international awards and recognition. There's even a documentary about him called The Man Who Stopped the Desert. But here's what's really worth celebrating. This wasn't a top-down solution imposed by governments or international organizations. It was bottom-up, farmer-led, indigenous knowledge adapted and applied by the people who needed it most. The NGOs and governments came later, providing support and helping to scale up. But the innovation, the persistence, the actual digging, that was done by African farmers who refused to give up on their land. Compare that to some of the grandiose schemes that have been proposed for combating desertification. Massive irrigation projects that require billions in infrastructure. Industrial-scale tree planting that often fails because the wrong species are used, or there's no plan for maintenance. High-tech solutions that look great in PowerPoint presentations but collapse in the real world. The ZE technique succeeds precisely because it's simple, adaptable, and controlled by the farmers themselves. The broader lesson here is profound. Some of the world's most pressing environmental challenges might not require cutting-edge technology or massive capital investment. Sometimes they require listening to traditional knowledge, supporting local communities, and trusting people to solve their own problems when given the right tools and information. The Sahel is still fragile. Climate change is real and accelerating. Conflicts over resources continue. Population growth puts pressure on the land. The desert hasn't been defeated, but it's been pushed back. Millions of acres that were lost have been reclaimed. Communities that were on the brink have found a path forward. And it started with people digging half-moon-shaped holes in the ground. So the next time someone tells you that environmental problems are too big to solve, or that poverty-stricken regions can't innovate, or that traditional knowledge is outdated, remember the Sahel. Remember the millions of pits, one crescent at a time, armed with nothing but hose and determination, and a refusal to accept that the desert had won. Thanks for watching. If you want more stories about how humans are quietly doing amazing things when nobody's looking, you know what to do.